students. Swami Vivekananda once said, if a poor boy cannot come to education, education must go to him. Mr. Anand Kumar has lived by this quote. It is believed that education is the foundation of one's career, but these days individuals or institutions are using it as a lucrative business model. Mr. Kumar has changed this odds in this case. Anand Kumar is an Indian mathematician educator best known for his Super 30 program, which he started in Patna, Bihar, known for coaching the underprivileged students for IITs in the entrance examination for Indian Institute of Technology. Anand Kumar was born in Bihar. His father was a clerk in the Postal Department of India. His family could not afford private schooling for children, so Anand had to attend a Hindi medium government school where he developed his keen interest for mathematics. During his graduation, Kumar submitted papers on number theory, which was published in Mathematical Spectrum, and Kumar secured the admission to University of Cambridge but could not attend because of his father's death and financial condition of the family. In the later years, Anand had to go through various odds for running his family, and he had done several other kinds of jobs which are not considered to be very good. He leased in the later part, he leased an apartment for giving coaching to the underprivileged students so that they can have a better future. His works were recognized by various institutions, IITs, Discovery Channel, Harvard University, etc. In the year 2018, 422 students out of his 510 had made to the IITs. Kumar had spoken at an MIT, Harvard about his program for students.
Hello, Ishik.
Yes, sir.
Can you hear me?
Yes, sir.
So I think you are introducing the wrong person. I am not.
Yes, sir. Yes, sir.
Actually, these are some rituals we do daily. In every session, we like dedicate the session to a one.
Okay. Sorry. Sorry. Okay. Thank you.
Okay. I'm shortly ending this and reaching to your introduction part, sir. Anand Kumar was also inducted in the Limca Book of Records in 2009 for his contributions in helping the poor students. The Time magazine also included him in the Super 30 list of the best of Asia. Kumar was also, apart from various other awards, Kumar was also awarded with the Rashtriya Bal Kalyan Award from the Indian President Ramnath Kovind. Anand Kumar was also conferred honorary PhD from the National Institute of Technology. Apart from all this, Kumar has been awarded several other awards from time to time to recognize his work. Mr. Kumar deeply believes in the thought that education is free for all, as it should be, and there should be no hindrance to any children when it comes to education. So now I would like to introduce our research person for the 16th session, Dr. Ramesh Chandra Das. Dr. Ramesh Chandra Das sir is currently a professor at the Department of Economics of Vidyasagar University, West Bengal, India, with about 25 years of research and teaching experience. His master's, MPhil, and PhD degrees in economics are from the University of Calcutta. His major areas of research are applied macroeconomics, environmental economics, and political economics. Dr. Das has contributed several research papers to the journals of reputed publishers such as Springer, Taylor and Francis, Elsevier, MDPI, Sage, and IGI Global. He has published several edited volumes with the publishers such as IGI Global, Emerald, Routledge, Springer, which are catalogued in the libraries of the world's most reputed universities. Besides, he has written 3 reference books on microeconomics, macroeconomics, and managerial economics with national and international publishers for different fields of students and academicians. Dr. Das has been constantly engaged in the review books of the review works of the research paper with the publishers such as Springer, Taylor and Francis, IGI Global, Wiley, Sage, Emerald, Frontiers, MDPI, and Insider Science. Besides, he has completed 3 minor research projects with the University Grant Commission, India. Dr. Das has also been acting as an editor-chief in a couple of reputed journals in India. I welcome you, sir, and request you to take the stage.
Sir, I welcome you again to our FDP, and the session is yours, sir.
Okay, thank you for the introduction. Let me share the screen first. So, good evening, everybody. First of all, I offer my sincere thanks to the members of the organizing committee for inviting me to deliver a topic on the related field of this FDP program. But yeah, the Honorable Vice Chancellors of Assam University and Vidyasagar University, the respected deans of the two universities, the faculty members of Department of Business Administration, Assam University, faculty members of Department of Economics and Department of Business Administration of Vidyasagar University, the technical support staff, and the participants. So, is my PPT visible, please? Deepjyoti?
Visible, sir. Visible, visible.
Okay. Thank you. So, I start my lecture. Already the FDP has passed its first phase, and I hope you have learned a lot in statistics and econometrics. Besides other multidisciplinary subjects, the topic which I have chosen to cover here is forecasting in economics, or forecasting of any economic data, and the title is basically economic forecasting, special emphasis on ARIMA model. In the real world, we mostly face confrontations or some confusions regarding to related terms in my topic of discussion today, that is forecasting and prediction. The first one is logical. It has some sound mathematical base. On the other hand, the second one is basically, it depends on upon some sentiments, some biasness, some beliefs, etc. So forecasting actually it's a process of analyzing and elucidating a future state concerning any operation being undertaken. That is the main definition of forecasting. This process takes the past and the current information into account in a bid to predict facts for the future events. This is forecasting. On the other hand, prediction, it is a statement which tries to explain a possible outcome or future event. Companies and governments use predictions determined by experts to guide through uncertain projects despite their level of uncertainties. They are highly risky, and the actual results may deviate from predictable results. So, forecasting and prediction, though they have some similarities in common terms, but they have huge dissimilarities in terms of the technical base of these two concepts. A forecast refers to a calculation or an estimation which uses data from previous events like the past period's values combined with recent trends to come up a future event outcome. So that is forecasting. Once we go for predicting something, we do not think of any current data, past data, everything. We actually do something, think something, what we believe, what we actually have our sentiments regarding a particular event. Suppose if we go through our T20 cricket matches now, these T20 format is basically highly dynamic cricket system compared to our so-called test cricket. Test cricket is basically static. To our common view, it is a static game. Some things are in some slots, the match gets some huge extra importance. Otherwise, to common people or to the people of the modern generation, young generation, they basically dislike test. But to them, one-day cricket is somewhat more dynamic compared to test. But T20 is very amazing. It is very exciting. In each and every ball, there are some changes, and sometimes the broadcasters, seek the opinion from the common viewers, the fans who are present in the stadium, what will be the scenario of the India-Pakistan match, what will be the result, whether Babar Ali will beat India, Virat Kohli, or whether Rohit Sharma will be the key person to the T20 match winning compared to Virat Kohli. Always we see some sorts of valuation and prediction by the fans sitting inside the stadium, right? So one over is over, then new forecast or new prediction comes. The same person is giving another opinion. That means always the T20 match gives you some sort of excitement. Always the viewers make themselves busy in viewing all the balls because every one ball is important in T20. That means there are predictions from the ants club, but once the forecasting is there, the statisticians, the calculators, the computers, those who are calculating what will the score of the particular team at the end of 20 over, they are actually starting. They actually start forecasting from the first over. What is the current run rate for the first over? If it is 6, then the straight away they will forecast that it will be 120 after the end of 20 over. If the second over has 7 is the run rate, then they will forecast that there will total around 140 will be the total score, around 140. So these types of forecasting is there, all sorts of computations, logic, estimations are there. So prediction is forecasting is basically prediction. That means it encompasses all sorts of predictions. But prediction is not forecasting. So forecasting is a huge set. Prediction is a subset of this forecasting. That's why the common terminology, prediction and forecasting, do not go in the same way. Clear? So that is the very basic introduction to why we should think of forecasting, we should think of prediction. In economics, in business, we actually think of the term forecast. So why it is important for business and economics? So what the business owners do, they actually make some decision-making processes. Clear? That's why forecasting to them is valuable because it gives the ability to make informed business decisions and develop data-driven strategies. Clear?
Sir, sorry to
Second
interrupt,
one,
sir. Sir, are you changing the slides?
no. This
Okay.
is very much introduction.
Okay.
This story, right? I will change the slide once it is required.
Fine, sir. Fine.
Okay. So second one, if we think of the necessity of forecasting for business houses, it helps them predict potential issues, make better decisions, and measure the impact of those decisions. Say the third one is I pointed out some of the key necessities of forecasting for the business houses as well as the economists or economic system. Forecasting looks at looks at how hidden currents in the present mix, signaling the possible changes in the direction of companies. That the primary goal of forecasting is to identify the full range of possibilities. Clear? And it helps the business to make planning for both the short run and long run. So these are the common points of necessities to a business house, why they will go for forecasting. But for economics, it is not a business person. It thinks of the global system, it thinks of the total system. That's why our economists can think of how the public policy will be, whether the public distribution system will be continued even after that, after the say, uh, somewhat closure of COVID impact, whether the rational system will continue, whether monetary policy will be to make the same rate of interest, same reserve ratios, bank rates, repo rates, reverse repo rates, everything. So these are all important for our economists or economic planners. Similarly, those who are share brokers, investors, they always go for forecasting on the basis of the past events, on the basis of the current information, on the basis of past and present fundamentals. Clear? The Ukraine-Russia crisis that becomes an important part of forecasting today. The rising global crude oil prices, these have become the important aspects of forecasting to the economists. So that's why we should think of forecasting in a very careful manner. That most of the countries are today facing rising population. That means population aging is there. Once the population aging is there, most of the Western countries are facing this population aging problem. That means once the old age population increases, the natural demand will be for healthcare, natural demand will be for pensions. So how government will think of these aged people? How they will the aged people think of medical insurance, etc., for the coming years, coming days, etc., etc. So that is another aspect. And the growing housing demand. Once there are urbanization process, we are moving from rural belt to urban belt. We are seeking of apartments, flats, etc. So there is increase in housing market. So how much the housing bubble will be there? Whether there will be some sort of housing crisis like US subprime lending crisis or not? These types of issues are important while we discuss the necessity of forecasting in economics. So under the background of this very basic introduction on forecasting, I start my lecture on the basis of how we do forecasting economics and how the AR and MA ARMA model will work, because it is my special emphasis area, ARIMA model, and I will go for box Jenkins tools. So before going to detail the ARIMA structure, I will go first focus upon the methods of forecasting, what we actually teach in UG levels, in business schools, etc. So I'm going to detail in this aspect. So I am now changing my slides. So this is the methods of forecasting. Usually, I use the term usually. There are two broad methods of forecasting in economics: statistical method and econometric. These are two broad. There are so many other methods also. The business houses use other methods, but I stick to these two methods: statistical and econometric. On statistical head, there again the popular one is trend projection. Trend projection method. There is a time, because it is trend. There is a time component. Time projection or trend projection, it has again two components, sub-components: linear projection or linear trend projection and non-linear trend. So I will come to very preliminary or basic concept of these two concepts. And then the econometric method, there are again two methods: classical method, where we use actually the OLS, ordinary least squares technique, to estimate one model, then forecast on the basis of this estimated model or estimated parameters. And the second one is time series method. And the ARIMA structure is basically time series method. So most of my discussion focus will be on this time series method. Again, out of the time series econometric method, we have so many variants of time series econometric methods of forecasting. The most popular one is univariate ARIMA method. That is the Box-Jenkins method. ARIMA, auto-regressive, integrated, moving average. Those participants who are not from pure economics, not from statistics, I will have to discuss some terminology there. So ARIMA means auto-regressive, integrated, moving average. And the second one is also important, particularly important in the modern economic structure. It is multivariate VAR method. Multivariate means there will be combination of many variables. There is some vector type analysis. So VAR means vector auto regression method. Now come to the statistical method. The first one is linear trend projection method. Suppose in a variable y, it depends on t. Clear? So that means how economy is moving. If we think of India's post-independence structure, it actually its planning phase started from 1950-51. So this is the origin of this economy. It started from some values because the British government had given some values to us, had given some ways to us. That is our origin. Here from that a particular income and wealth, we are now in 2022 around $3.5 trillion economy. Clear? So why our GDP actually say y or any variable y is moving over time. So I can write this equation as y equal to alpha plus beta t, yt equal to alpha beta t. So yt is moving over time. Alpha, beta, two constants. Alpha is intercept, beta is slope constant. So we can simply estimate this model to any method, simple curve fitting method, simple least square method, whatever you can use. Our purpose is to estimate alpha and beta. Unless we estimate this alpha and beta, I cannot estimate the value of y on a particular time t. T equal to say 2010. What will be the particular value of y in 2010 if alpha is equal to something, beta is equal to something, or alpha estimated value means alpha hat and beta hat. So if we have alpha and beta hat, then we can estimate what will be the value of this particular y in say 2023, 24, 25, some future periods. So since our two unknowns are there, alpha and beta, so we should need at least two normal equations. One for alpha and one for beta. So first normal equation is basically just you sum up both the sides over all the n number of observations, n number of time periods. So that is the left hand side yt, it will be summation yt or summation yi will be equal to summation alpha over the n period, it will be n into alpha plus beta summation ti. So this is the first normal equation. I am moving the cursor over the first normal equation. This one. And for the second one, just to multiply both sides by ti and again sum up over the n value. So summation ti yi equal to alpha summation ti plus beta summation ti square. So these two normal equations are there. We will have to calculate or estimate or solve for alpha and beta, and these two values will be actually alpha hat and beta hat. First we calculate beta hat. This is the beta hat formula. If you have some knowledge on ordinary least square OLS technique, then actually the beta is basically 1 by n summation xi yi minus x bar y bar divided by variance. So this is something similar to that particular expression of beta hat. So if you have your y data, if you have your time data, then you can calculate easily the summation ti yi, summation ti into summation y by n, summation ti square, and summation ti square by n. So that means in square, that means you will be able to calculate beta hat. And if you have beta hat, just to put this beta hat here, so what will be the alpha hat? It will be alpha equal to y hat, that is your estimated y minus beta hat t. So this is one your alpha hat equal to beta y bar. It will be basically your mean value minus beta hat t bar. So this is your estimated equation yt equal to alpha hat plus beta hat t. Right. Once you have this model for any particular time, now you forecast. Now you use your value of t here. Suppose you have 10 years data or India's 75 years data. So what will happen? So if you count 1947, then you have your 75 years data. So you want to say forecast 76 years value of this particular GDP of India. So what will you do? Just you put this t as another year. So you will get your new value on the basis of this estimated alpha and estimated beta. So this is very primary work. You can easily use your simple calculator. Then you can calculate it by hand, no problem. Or you can use your Excel. No additional package will be there. Second one is non-linear trend projection. That means in our earlier model it was y equal to alpha plus beta t. Now there will be some non-linear terms of t. It may be t square, it may be t cube, etc. So if there is t square term, we will have our quadratic form. If it is t cube term, it is cubic form. So you may use so many polynomials. So you will have a set of polynomials. But our capacity of computing as economics students, economics teachers, we have some limitations. We cannot go beyond our capacity. So we can work for quadratic or cubic function. So if you go for quadratic function estimation, what will happen? Here you have your three parameters. Here there are three parameters: alpha, beta, and gamma. Beta is for linear, gamma is for non-linear. So if there are three parameters, you will need at least three normalities. In the same way, first one we can sum up both sides for the n values. The second one will multiply both sides by ti, then sum up. Then the third one will multiply both sides by ti square, then sum up. So these three are normalities, right? So you can use any mathematical, any simple equation solution technique. You can simply use the class 7-8 technique, or you can use the Cramer's rule. You will find alpha hat, beta hat, and gamma hat. So once you have your estimated equation y equal to alpha hat, beta hat t plus gamma hat t square, then again for any future periods, you will have to replace these t values. Then you will get another forecast. So this is the non-linear trend projection method. Now come to the classical econometric method, that is the OLS, ordinary least square. Why it is econometrics, not statistics? Because here we will have to include some unknown thing. That means everything in the today's world is deterministic. Some part of it is yet to be determined. Clear? That means if we think of our simple demand function, once we relate demand for any commodity to its price, then there are so many other variables, left out variables. It may be the income of the household or consumer. It may be the price of the related commodities. It may be so many other factors. So there are left out factors. On the other hand, if we have uh, GDP and government expenditure, if we calculate the trend or change of GDP to public spending, then there are so many other factors which may be possible for explaining our GDP. If we consider only this government factor, public sector factor, then we are actually omitting the monetary sector. We are omitting the trade sector. So many omitted variables are there. That's why we need to capture these omitted variables. And econometrics does this task very well by introducing a random factor, random disturbance star U. So our model is looks now x equal to alpha plus beta m plus u. If you think of our earlier equations, y equal to alpha plus beta t and u. So this is the linear demand function. Suppose it is the linear demand function x equal to alpha beta m plus q, and this u is actually it follows classical. That means it has constant variance, it has zero mean, constant variance, non-multipolarity, no heterogeneity, everything, no autocorrelation, very nice property holder, this U. So if we estimate this model x equal to alpha beta m plus u, what will have? Suppose this dark line. This dark line is the original or actual or observed. Here, but if we make the estimation through some least square technique, that is, we minimize the error. What is the error? That u, the role of other factors. So once you justify the role of m upon x, then you will have to minimize the role of other factors, the u. So we will have to minimize the error, and that is done through least square of error. So this line, this light line, that is x equal to this one, that is the straight line moving upward. It is the best fitted line here. It gives you estimated function alpha hat plus beta hat m. Here alpha hat, this one x equal to alpha hat plus beta hat m, and this error has some standard normal distribution, and that means there are some negative and some positive terms. Sometimes actual process the observe, sometimes observe process the actual. That means there is a combination of some negative and positive, and at the end, all combination of these two negative and positive items will be added up to zero. So this is the estimation procedure. Once you have your alpha hat, beta hat, you will again be able to estimate your model to get some forecast values of this x depending upon m through the estimated values of alpha hat, alpha and beta. Clear? These are the basis of statistical and econometric, classical econometric methods. So I give you one example before going to the time series econometrics. I again give you the T20 cricket match example. So this one is the scorecard. Simple example of a T20 cricket match. There are 20 overs. There runs from first over to last over. Total is 187. This is the cumulative figure over what you see in the television. Whenever they show the graphs, you have this cumulative run. Clear? It is 187 at the end of 20 over for this particular team. if they go through these types of runs in each over, 6, 8, 10, 12, 14, 16, this way, then at the end of 20th over, there will be total 187 on the board. And if for each over, there can be run rate, current run, CRR. That is in the first over, this is basically 6 by 1, 6. The second over, it is 6 plus 8, 14 divided by 2, that is 7. The third over, it is 24, 6 plus 8, 14 plus 10, 24 by 8, 3, that is 8. In the same way, we have calculated, actually I have calculated the run rate in each and every over. Clear? But in T20, actually, there is one power play, first 6 overs, but in the last couple of overs, we get the power hit, that is some sort of some power hit overs. So I actually want to show that if the television channel, if the broadcaster, if the statisticians show the forecasting of runs from the very first over to sixth over, that is the power play. So how the changes will be clear? Scenario 1, I actually made scenario analysis. It is basically done through Excel. There is no need to run any package. Scenario 1 to scenario 6, that is first over to sixth over. In the first over, at the end of first over, the total run on the board is 6. So if the statistician make forecasting of the remaining 19 overs, what will the total run on the basis of this current rate? 6. So there will be 120 runs. 6 into 20 over, that is 120 runs. So in the scenario 1, forecast from over 1, that is actually 120. Now come to second scenario. What is the second scenario? That I am taking the second overs run rate as the basis of forecast for the remaining 18 overs. So what happens in the second over? The run rate is 7. So in the remaining over, there will be increase of total runs by 7 units per over. So in the second over, the total run on the board was 14, 6 plus 8, but the current run rate was 7. So in the next over, there will be increase of 7 runs per over. 14, 21, 28, etc. But at the end of the match innings, there will be 140 on board. If the forecast is true from the second over, the forecast is correct from second over. That means in all the remaining over, there will be on an average 7 runs per over. There is no change of runs. In the third scenario, what again? The third scenario, the average run or the current run rate is 8. So in the next over, there will be 8 runs addition. So in the third scenario, 6, 14, 24, then you add up all the overs by 8 runs, 32, 40, 48. In this way, the total will be then 160. So scenario is changing, the forecast value is also changing. Scenario 4, the fourth over, 9 is the current run rate. So in the remaining overs, 9 will be the addition, 36 to 45, 45 to 54 this way, 180 will be the score. And in the same way, in the sixth over, there is actually 11 is the run rate. Clear? There is a huge run. Say sixth over, 16 was the score from the batsman. So 11 is the average run rate or current run rate on that particular sixth over. So once we change the scenario, then there will be change of this run. It will be 290. So what happens? Scenario is changing, the forecast is changing. So once the 19th over ends, actually there will be the identity between forecast and actual. Clear? So this is the way to which the statistician in the stadium is forecast all other values or the runs in the other overs, etc., etc. This way. So you can go on increasing the number over from 6 to 7, 8, 9, 10, 11, 12. Anyway, you get so many scenarios. Every scenario has its own meaning. If a certain circumstance happens, then this will be the round. If another circumstance appears, then there will be another round. This way, this is a very simple arithmetic. There is nothing to do with any more calculations. So just you plot these scenarios in diagram. Clear? These are there are 6 scenarios, 6 diagrams, and one is cumulative run. That is the actual run. That is 187. The 6th category, that is scenario 6, gives you highest 220 on board, and the lowest category, that is over one prediction from forecast from first over to one. But this gap goes on increasing if the batsmen hit more and more runs in the medium overs, and the gap will be closer and closer if they lose wickets and score less and less runs. So this is the very simple scenario of forecasting. Very simple example also. So now come to my topic actually. That is the time series econometric forecasting. So in time series econometrics, there are basically 4 important topics. Clear? First one is forecasting with linear regression models. Second one is univariate time series forecasting. That is the ARIMA structure with the help of Box Jenkins methodology. The third one is multivariate time series, that is multivariate time series forecasting using vector auto regression bar model. And finally, it is not important to forecasting, but it is important to the topic which we usually discuss in time series econometrics, that is the nature of causality. Here, which variable causes which one, or how many set of variables cause say particular variable. So how GDP is caused by say public policy, or how GDP is caused by both public and monetary policy. These types of way of causation, way of causality, these are also explained and analyzed in time series. So my task is univariate forecasting, that is the ARIMA structure. Clear? So again, I come to a system of discussion again. That is, if we think of our the example on the T20 match, what we saw that the current value as well as some past values explain the next values. Clear? That means the importance of current as well as past values as is there upon predicting a value of the variable in some future time, right? So if you think of our first and second overs, then the remaining 18 overs, that is my future. The statistician, the scorers did not know what will happen in the next over, but they can only calculate that is what will happen if the first overs run rate appears or the second overs run rate appears. That means the particular variable's value in any period will actually be decided by the past values. That means history becomes an important component. So we should not omit studying history. We need to know our historical aspects of Indian economy. Clear? So that means there should be a discussion what should the data, how the data is generated. If we go for our earlier example, that is data generation is through our past values. Clear? Now suppose there are certain uncertain events. That is, in the seventh over, there is some remarkable stroke by a batsman. He scores a 36 runs, 6 sixes in the run, like Douglas. So what would happen? The total scenery would change. Clear? But after, if in the eighth over that particular batsman got out, then the scenery again will change. That means there is some uncertainty. These uncertain values are actually error. Clear? That is, the value of any particular variable in some future period will be decided by its past values and current value, as well as some unknown terms. Clear? So these are two data generating process. So once we have the macroeconomic data in economics, we should always think of how the today's $3.5 trillion economy today is possible on the basis of our 1947 study. That is, the data has been generated. All the time series data actually generated through these two components. One is the past values and current value. That is called the auto-regressive components, AR. And another is the uncertain, unknown error values, that is called moving average. So that's why we have the data generating process. That is, the next slide is coming. This one. So we need to start the data generating process. What I explained there. Here is another example, very popular example I usually give to our scholars. That is, just think of AR process, auto-regressive process. That is, past values of the variable and the error term generate the data. Here, that is, the example is the performance of a research scholar. It depends on how he was or she was at his or her master's level, how the knowledge he or she had generated from his or her master's level. Again, the master's level scores or academic output also depended upon the graduation scores. Graduation also depended upon school level scores. School level scores also depended upon primary level scores. And primary level scores depend upon the very first day of your learning, when you started writing how to write A, B, C, etc. So this is the source of data. That is how you were in your first day of learning, when your parents or some priests in our culture, they give the chalk or pen to the particular baby. He or she write A, B, C, etc. or in all our regional languages, in our Bengali or etc. etc. So this is the source. Clear? So in the very first day of life, this particular baby actually generates its human capital structure. It's or his or her human capital base. Once he or she comes to research activity, that becomes the intellectual capital. So today's intellectual capital is basically the human capital formation, which started from the very first day of learning. That is the AR process. What is about MA process? The same example can be there. Whenever you are in the first day of learning, all babies actually cannot write A, B, or A in the same fashion. Someone can write or draw in a very good way, someone else very bad way. That means there are some uncertain factors. What are they? They may be the genes, the parents' gene. There may be the gene of the grandparents. There may be the unidentified or unknown capacity of the brain of this particular child. These are all unknown. Clear? This is the component of MA process. Even if we give the example of COVID-19. Once it hit China in January 21st, 2020, nobody was aware of this uh, cattle disease, cattle virus. Nobody is aware. We are just joking. Some corona has come to China. Some people are getting died. This way we are just discussing and joking with ourselves. But what it did in the last 2 years, we cannot imagine, right? So that even today there are some unknown features also about COVID-19. That means these are all unknown, but they have some impact. COVID has proved how the unknown factors may be vital to the economy, society as a whole. The global leaders are trembling. What will be the policies to tackle this crisis or one sort of pandemic, right? So these are the in every data we actually have these two types of data generating processes. One is AR, auto-regressing. When the past values are important, the YT determined by YT minus 1, YT minus 2, dot, 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 to YT minus P. So we are moving P periods back. It may be 2 years, it may be 75 years, or it may be 100 years. On the other hand, there are some uncertain factors, moving average. So uncertainty means there can be some positive values in 1 year, there can be again negative values in another year. That means this moving average can be summed up to 0. But AR values cannot be summed up to 0. So that's why if we combine the two generating processes, we have our ARMA model. ARMA, auto regressing moving average. Now there is an additional term, I, ARIMA, I for order of integration. That means I will come to this point detailing in some after some slides. So I for order of integration. How many times you are differentiating your series, differentiate your data series to get the series to be stationary. So note down the term stationary. So maximum time series data actually are non-stationary. Clear? So I will have to make the difference between stationary and non-stationary here. I am giving the some concepts. That is, suppose in say 20 over match. In all the overs, 6 runs are scored. 6, 6, 6, 6, 6, 6, 20. So if you plot these 20 overs data in an Excel sheet, you will find a graph that is basically a horizontal line. That means the second over 6 runs actually does not depend on the first over 6 runs. Third over 6 runs actually doesn't depend on the second over 6 runs. Or 20th over 6 runs actually doesn't depend on the runs of 19, 18 to dot 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 first over. That gives you a station. The value is still around a constant value. The series is still or moving to around a constant value. This is the 6 runs per over. This is the constant value. But if you plot the data in another way, if you just think of the scenario 1, 2, 3, 4, 5, 6, you will have some rising trends. There are some fluctuations. In some over there are huge runs, there are in the next over there are very low runs. That means these data are non-stable. That means actually the next overs runs actually decided by the immediate past overs run. All these chain of words relationship will work up to 20th over. So if we have macro data, that is macroeconomic data, like our GDP, like our interest rate, like the exchange rate, like the trade ratio, everything, they actually represent the non-stationary data. So once there is non-stationarity, there is some hazardous item. We cannot control them. Clear? So we can control Yuvraj Singh at the end of fifth ball of this particular over when he hit 6 runs in the first 5 balls to root Stuart Broad from England. So Yuvraj Singh knew that in the last ball of this particular over, there will be another 6. That is very highly volatile. We cannot control. We could not control at that time the Yuvraj. That means in any non-stationary or time series data, actually there are the situations of non-stationarity. If we want to control this non-stationarity, we will convert these non-stationary values or variables into stationary variables. That means we will have to make differentiation. Yt minus yt minus 1, yt minus 2 minus yt minus 1, yt. This way we will be differentiating the values, and the series will be then first difference series dy. It was originally in level form y or yt. Now it is dyt. Dyt means yt minus 1, yt minus 1 minus yt minus 2 dot 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 all the last 20, 30, 45, 50 years. Then you have the new series dy. Then you plot this dyt in again Excel sheet, draw a line diagram. If you find any sort of stationary feature like the 666 runs each and every over, then there can be the controlling of this non-stationary nature of this data. If you do not get this stationarity after the first differentiation, you may also opt for second differentiation. That is d square yt or d of y. Then you will have another series. This is called second difference series. We again go for plotting these one in Excel sheet and diagrams. You then find in most of the cases, even the vibrant Chinese economy, most of the Chinese macro variables are stationary at the second difference. Here, India GDP is stationary second difference, not first difference, because there are some jumping income rising in India and China. Clear? But if you go for US economy, European economies, that is Western European economies, their GDP are actually first difference. They are not second difference because there is no such jump. But if you incorporate some crisis phases, like say global financial crisis of 2007 to 2009, then if you have say the around say 2006 to 2009, there are actually 16 to 20 quarters, 6, 7, 8, 9, 10, 2010, there are 5 into 4, 20 quarters. So if you plot the 20 quarters, then you will find the non-stationarity at the first difference also. Clear? So the primary task is to make the series from non-stationary to stationary. Then we can go for estimation. That's why the I component in ARIMA is important. So now I come to my next slide. This is another example which I was actually giving example US economies GDP data. Some situations on GDP of USA for 1982 to 2019. I actually internationally omitted the COVID period to find AR and MA factors. Here, this situation 1 is the original situation, actual situation. This data was there, but for this 38 period data, there are no problem with the data except these 3 red color data. What you see? Just look at this diagram. This situation 1. In this page, that is the red color marked numbers 7, 8, 9. Here there is a break due to global financial crisis. The housing bubble got burst in the US market. Due to this, the GDP of USA and most of the European countries, even our GDP also got halted, got down. Yeah. So this way, if we draw an estimated line here, the estimated, that is y equal to alpha plus beta t, result is this one. 30,000 crore dollar was the coefficient of this time variable. That is, if on an average 1 year process, the GDP of USA increases by 30,000 crore dollar. Clear? Now, just now, think of another scenario. Situation 2. What I have done, that I did not take into account this crisis effect. I actually made the extrapolation of this data from the source 1982 to 2006. Then I filled these 3 years data. Then I get this one. Situation 2, that gives you the coefficient as 40,000 crore. Clear? Dollar. So in the past scenario, when the crisis was present, there was on an average 30,000 crore dollar increase of GDP was there. So once I linearize the shock effect, I actually omitted the shock effect. Then we have the increase on an average is 40,000 crore dollar because of this minimization of non-stress. Clear? So if we make the difference of these two series now, I get this one. This series from the 2007 to 2009. This one is the diagram. Then what we see, there are some negative values in the crisis phase. That is, the actual value was actually less compared to my estimated value. The blue color value was greater compared to the red color value, because I control these shocks through my the past periods value. Clear? So what is the importance of this analysis or example? That is, whenever I go to situation 2, I actually measure how much AR is there, how much MA is there. These red and blue color, basically the MA. Unknown parameters, unknown shock. The US government could not imagine what was going to be there in the next couple of quarters. Clear? So that is the combination of AR and MA factors. Right? Now, examples are popular examples are over. Now I am coming to the essence of the ARIMA model. Now, how to structureize the AR and MA. Here, now I consider an AR process with order P numbers of order, or I can back to my history in P periods lag. So yt equal to phi 1 yt minus 1, that is my past periods. That is today's y is actually explained by just yesterday's y. Then day after yesterday. So I am going back to my past values, history, and one error. Clear? And if you just simplify this one, summation phi I yt minus yi plus ut. That ut is white. Whiteness means it has good properties. It has 0 means there is summation or expected value of ut is 0. Variance is constant. Expectation of ut square is sigma square c. There is no covariance among the error of different periods. There is 0 covariance. Very nice property. White noise is very important one and is very nice property. So I would have to estimate the values of y on the basis of phi 1, 2, 3 ... So then we need some operator system, lag operator system. So we use lag operator. That means this phi 1 is yt minus 1. I can write yt minus 1 as L yt or L to the power 1 yt. So L1 yt means actually yt minus 1. L2 or L square yt is basically yt minus 2. So L to the power pyt means yt minus 2. So I have now the L operator equation yt equal to phi 1 L yt, phi 2 L square yt dot 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 this one plus ut. I can again make the summation of these expressions. Summation phi I L to the power I yt plus. That is AR process. Now come to MA process. MA process means only there are white noise terms, all random terms, all are white noise. That means their summation expected value of these noise terms are always zero. Variances are constant. There are no covariance also. So this the MA process actually again there are so many past periods error terms. There are Q terms of MA process. So UT the past period, then lag period theta 1 UT minus 1. In the AR process the coefficient was 5. In the MA process the coefficient theta. Theta 1 this one, and then again UT equal to theta I UT minus 1, right? Again you this one. So now you come to the some interesting property of AR and MA, because these two are actually invertible. And that means the properties of features of AR can be converted to MA. Again, the MA properties can be converted to AR. There is invertibility conditions here. So now I again write this AR process. Then use lag operator. I get this one. It was already there. Yt equal to summation phi I L to the power I yt plus ut. Now I take these L terms to the left hand side. Yt minus phi 1 Lyt minus phi 2 x square yt dot dot dot, and the right hand side is ut. Now take yt as common because there are no yt minus 1, yt minus 2, only yt is there. The lag operator actually controls these lags. So yt is common term 1 minus phi 1 L minus phi 2 L square minus phi 2 L2 dot 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 this one plus ut. Here I can write this 1 minus this term as phi of L. So this phi of L into yt, this yt equal to ut, where phi L is actually 1 minus phi 1 L minus phi square dot 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 this one. Clear? So if we need this yt now, this yt, I actually take this phi L to the right hand side. That means the right hand side will be inverse. So yt will be equal to phi L inverse ut. That is this one phi L inverse ut. Clear? And this is your ut plus inverse. So this now you decompose this one, that is phi L inverse can be decomposed. This is the Old's WOLD's Old's decomposition technique. That is, you can just spread up this phi L inverse to get some positive expression. That is phi L plus phi L square plus phi L cube dot 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 into ut. Then you multiply all the terms by u. Phi L ut, phi L square ut. This one. So this is your actually you convert this one. So you had your expression in y terms in the AR process. Now you are with u terms. That means you are actually coming to the MA process. So this expression can then be added up as yt equal to ut plus summation theta I ut minus I. What is ut plus summation theta I ut minus? That was our MA process. This one. So AR can be inverted to MA process. The same way, we can start from MA process, then again we can get this AR process just to calculate in the reverse direction. You will then arrive at this ARP. This is very important feature because it will be required while we get going for testing or forecasting some values of a particular variable. So, what is the property, stationary property of ARP process? Stationary means the simple logic is there, no values of the variable in terms of its uh, statistical measures like mean, variance, covariance, they will always be time independent. Clear? Mean will not depend upon time, variance will not depend upon time, etc. That is, today's value will not depend upon the past. This clear? So how can we go to establish whether there is stationarity property or not? So you have your here equation y equal phi L inverse ut. There, this one I again expand this one like the previous slide. This one is the expansion or decomposition. So if we make this phi L term to 0, if we make this phi L to be 0, then only remains the y thesis as y equal to u. That is ut plus phi L ut this way. So if we keep this phi L term to be 0, that is phi L plus phi L square this term to be 0, then only we will have y equal to ut only. That is basically an MA process. An MA process is always stays. Clear? So this is that is the white noise term, and we can explain this one through this relations. But to have some critical features of a particular series, actually we need to have some two types of solutions are there. This is basically a difference equation type, right? Yt is a function of all yt minus 1 or yt minus I. That is a form of difference equation. So in any difference equation, there are two solutions. One is particular solution, another is complementary solution, right? Particular solution is basically the stationary solution, which is static. And the complementary solution is basically dynamism or some deviations from real scenario. So when there are some fluctuations, when there are some deviations from the equilibrium solution, equilibrium values, then we need to have our complementary solution. And for this complementary solution, we need to have characteristics equation and characteristic roots, right? So I use Z as the characteristic root for this complementary or for a characteristic equation. What is the ARP process then? This 1 minus phi L will be just replaced by phi Z square, etc. This one 1 minus phi 1 Z minus phi 1 Z square. This way equal to 0. So if the characteristic root Z lies outside the unit circle, that means if the value of Z is greater than 1, just to put this Z greater than 1, what will happen? That phi 1 should be less than 1. Otherwise, there will be no 0 value. So 1 minus all these terms will make 0 only if Z is greater than 1, then all phi should be less than 1. And that is the particular stationarity feature, that is Z should lie outside the unit circle or phi should lie inside the unit circle. So phi values will be less than 1 and Z's value will be greater than 1. So Z's value greater than 1 is actually consistent with phi's value less than 1. So for the stability property or stationarity property of the AR process, we need to have phi to be less than 1 or correspondingly Z to be greater than 1. This one. Just see, this is the unit circle. Clear? On the boundary, Z equal to 1 or phi equal to 1. So Z equal to 1 or phi equal to 1 means there is always non-stationary. On the outside of the boundary, what happens? Z is less than 1 or phi is greater than 1. That is the divergence situation. In the unit circle, within the unit circle, what we have? Z greater than 1, phi less than 1. That means actually the system is within the unit circle. That means phi is less than 1. That the series is convergent. So we need to have the convergence property, or we need to have the stationarity property. So it is phi less than 1 or Z greater than 1. Right? So just you take example. What is the example? Suppose I have very simple task of AR process, AR1 say. We had our ARP process, now it is AR1. That means there will be one period lag. Clear? So YT equal to YT minus plus UT. Phi is here 1, YT minus equal UT. So now you use your lag operator. YT minus 1 means LYT. Take YT as common, Y into 1 minus L equal UT. So now you introduce your characteristic equation or characteristic root. Now we replace this L by Z. What will be the characteristic equation? 1 minus Z equal to 0. The Z equal to 1. So Z equal to 1, that means the values are on the boundary of this unit circle. This is always non-stationary. Clear? That means this model YT equal to rho YT minus 1 plus UT, this is a random walk model. Random walk means there is no control over this model, like Dunker's movement. Here, so this is always unstable. So Z equal to 1, always unstable or always non-stationary. Now take another example. In the same way, the same AR1 process, but with some phi term in the YT minus 1 component. Then you have your YT minus phi YT minus 1. Again, your lag operator YT minus phi L YT equal to UT. Now you take Y common, 1 minus phi L equal to UT. Now your characteristic Z, what will be the characteristic equation? 1 minus phi Z equal to 0. You have replaced, we have replaced L by Z. So 1 minus phi Z equal to 0. What will be there? Phi Z equal to 1, means phi Z equal to 1, 0. So phi Z equal to 1. So if Z is greater than 1 here, then phi should be less than 1. Otherwise, phi into Z will never equal to 1. That means when there is Z greater than 1, phi should be less than 1. So our important feature property of any AR process would be that phi should be less than 1 for getting the system into stationary property. Clear? So there are certain properties of AR process, ARP process. That is, how can we, what is the value of mean of ARP process? What is the value of variance in ARP process? For the value of autocovariance in the ARP process, and what is the value of autocorrelation function? So these four properties, these four values of this particular ARP process are to be derived. I shall not go to detail of deriving this system. Actually, you will be getting this derivation from any economic economics book. So I am just giving the results of this one. So what will the value of mean under ARP process? This is expectation of YT mu by 1 minus phi 1. Since mu was a intercept term in this model, so that's why it was mu by 1 minus phi 1. If we omit this intercept term from this model, then there will be YT equal to only phi 1 YT minus 1 plus UT. Then the mean value will be 0. So ARP value in ARP process, mean may be constant or 0, that depending upon whether there is an intercept term or not. Now variance of AR1 process, simple example, YT equal phi 1 YT minus 1. In the same way, we do the Holt's decomposition. Then we have the variance is sigma square by 1 minus phi 1 square. Sigma square by 1 minus phi 1 square. the variance of AR1 process. What is the autocovariance? Autocovariance means that is the expectation of yt minus mean of yt into yt minus 1 minus mean of yt. Since this e of yt and e of yt minus 1 is 0, then actually these terms down to expectation of yt into yt minus 1. Then you replace the u terms from the MA process in this expression, then we'll get ACB autocovariance in order 1 equal this one, and some cross terms, and these terms actually variance terms. So we have actually autocovariance for lag 1 is actually phi 1 into sigma square by 1 minus 1 square. For lag 2 it will be phi 1 square into sigma square by this one. For lag 3 it will be phi 1 to the 3 sigma square this one dot dot dot. For ACB order P it will be actually phi 1 to the power P sigma square 1 minus phi 1 square. That is autocovariance ACB for order P. Then ACF auto correlation function. This is very important measure. It will help us to forecast the variable. ACF for any lag ACF1 is the ratio between autocovariance and variance. ACV1 by variance. Just you put the values here, they will get for lag 1 ACF1 is basically your phi 1. For lag 2 phi 1 square, for lag 3 phi 1 cube, for lag P phi 1 to the power P. Just you put the condition of stability, that is phi 1 less than 1. That means what will happen? So long as the lag length rises to infinity, that is P going to infinity, and phi 1 with less than 1 value, what will happen? ACF will fall exponentially. So for air process, the autocorrelation function should be exponentially declining if the stationarity or acceptability property is maintained. Otherwise, if there is steady declining, then there will be non-stationary. So there should be exponential falling or dramatic falling. There will be some spikes like something. That is the situation of autocorrelation function. Now the properties of MA process, again in the same way, since mean will be always 0 for any random disturbance, white noise terms, variance here, some other type of expression is there, sigma square by 1 plus theta 1 square. Now come to the autocovariance. This is actually the cross terms yt and yt minus 1. Then we will be getting autocovariance for order 1 as theta 1 sigma square, or for order 2 it will be all 0 because it is ACB for lag 1 or MA1 process is there. Clear? If we go on increasing the MA terms, MA1 to MA2, 3, then what will happen? That for the say for MA2 process up to MA2 there will be constant variance. Then there will be 0 autocovariance. This way the autocovariance of MA process will be derived. What is about ACF? Autocorrelation function. It is basically ACB by variance. It is again theta 1 by 1 plus theta 1 is constant for lag equal to 1, and when it crosses lag 1, it is again 0 because it is MA1 process. If it is MA2 process, then ACF should be ACF2 should be constant and ACF3 will be 0. So this way the ACF will be some spikes after say 1, 2, 3 lags. If it is MA1 process, there will be spike on first lag, after that it will be dying out. If it is MA2 process, the ACF autocorrelation function will be having spike in the second lag, after that it will be dying out. So this way the ACF will be derived. But if we combine the AR and MA process, what will be now? The ARMA process. That is, we will be combining all the autoregressive as well as all the moving average terms. That is your ARMA model. This one. Clear? Then you use lag operator, taking all the y terms left hand side, u terms right hand side. Then there is again phi L yt equal to mu plus theta L qt. Again, what will be yt? That will be phi L inverse into this term. That is again invertibility. So if you combine these ARMA, what you will have? That means there will be invertibility. So the characteristics of an ARMA model will be a combination of AR and MA models. But if you have, if you need to compare the scenarios of AR and MA processes, just we cannot use the ACF concept. Besides, we need partial autocorrelation. Partial means when yt equal to yt minus 1, then all other lag terms are omitted or the effects are omitted. That is why it is called partial autocorrelation. And this is also important while comparing the ARMA model and the features of the autocorrelation and partial autocorrelation function. So now we need to discuss another terminology, parallelogram. Parallelogram means which gives you the autocorrelation function and partial autocorrelation function. The diagrammatic views of ACN and PACF are given by parallelograms. So for AR process, what will happen? ACF will be geometrically or exponentially declining, but PACA will have some spikes. This here for MA, just reverse. ACF will have some spikes, but PACA will be gradually declining or damped sine wave. Once we have combined ARMA of order P and Q, there will be an exponentially declining both ACF and PACA. If we have this exponential declining or there are some spike points only, not some gradual declining of both the ACF and PACF, then only you can say that the model is model can be estimated, can be used for forecasting. So now I actually come to the forecasting method of ARIMA model. This is your ARMA P and Q order. That is AR is of P order and MA is of Q order. And I use another integration means I term ARIMA, and that is given by Box Jenkins methodology. They Box and Jenkins they use this ARIMA structure, and this is written as PDQ, P for the order of AR, Q for MA order, and D for number differencing. If D is 0, that means the values are level form stationary. If D is 1, the values of the variable are stationary at the first difference. If D is 2, they are second difference stationary. This way, the analysis will be there. So, what are the steps of forecasting under ARIMA structure or Box Jenkins? First one is identification. That means you need to identify what is the value of P, value of Q, and what is the value of D. The first one, that you will have to go for parallelograms, ACF, PACF. Then you will have to point out how many spikes are there, how many combination spikes are there in both the ACF and PACF in each parallelogram. Then you go for estimation. That is, if you find that the order of integration is 1, say first difference stationary, the order of AR is 1 and MA is 1. That is 1, 1, 1 is the ARIMA model. Then just you simply apply your OLS structure with the MA1 and AR1 terms. Then you estimate the model. You will get the coefficient of AR term, that is your phi or phi 1, we will also get the position of emitter, there is theta ones or thetas. Then you will have to go for some diagnostic checkings. That is, there are so many possibilities in any AR or MA processes, which combination will be taken for forecasting. That depends on which gives you the ideal or robust results. That should be through your diagnostic. And the last one is the forecasting. So now come to the first one, the identification of P, D, and first one is D. For D, we will have to test for unit. Clear? Whether this is level form stationary or first difference or second difference. This is the estimation equation, that is augmented decubicular model, and it's the first difference. Clear? Beta is equal to rho minus 1. Rho is basically your unit root. If rho equal to 1, beta equal to 0. If rho less than 1, beta is negative. Clear? This way, if you have this type of series, is stationary. Again, if you have this type of series, then non-stationary. So in these two, there are two possibilities. One is without trend estimation, and another is with trend estimation. And with trend means there can be some trend component, T component, time component. So alpha was there. Here again it is alpha. We add delta. Then again beta yt minus. So this delta t basically the trend component through which we can estimate or we can test whether the series are level form stationary, first difference or second difference stationary. Now I come to the real example or real estimation what I have done already. That is my it was a very nice work from my part. I cited paper right now. It was for COVID forecasting. When the 2020s scenario was there, the Delta case was there. So many developed countries with India, they were actually facing huge troubles in terms of number of cases and number of deaths. I actually wanted to forecast whether there will be rising trends of incidences from July 12 to September 11. Next 60 days or 2 months scenario, what will be there on the basis of the data from the very first day of the outbreak in China, Hubei province. Clear? So the 21st January 2020 was my first date of the data, and 11th July 2020 was the last point of my data. Around 90 days that there's 180 days data. Then I estimated forecast the next 60 days data. Clear? So the actual scenario was this. That the number of incidences only. Actual value of the selected countries: USA, UK, Italy, Spain, France, China, and India. These are the USA case. These are the India case. And in this scenario, there are the Western European countries: UK, Spain, Italy, and France. The original data. What we did, I simply went through the first step, second step, third step, fourth steps of this box Jenkins methodology. I tested the stationarity by means of decubicular test or augmented decubicular, and I found that in all the cases for USA, the level or order of integration was 2. Then it was second difference stationary. For UK, it was 1 because UK's fatality rate started declining. For Italy, its value was integration was 2. The middle values 2, 2, 2 for USA, 1, 1, 1 for UK, 2, 2, 2 for Italy. This way, I have calculated the unit root test and its result. Then I went for P and D, P and Q, order of MA, order of AR. So just you take the example of USA. Therefore, but you see that there are 1, 2, 3, 4, 5 possibilities. I thought I possibly would be the optimum possibilities through which we can go for diagnostic check. That is, we will estimate the coefficient of AR1 and MA1. Then we will have to find the adjusted R square. Then we will have to find the AIC, SIC information criteria, which the result which gives you statistically significant AR and MA coefficients with high R bar square, adjusted R square, with low AIC and SIC. Only this particular result of the particular combination will be taken for forecast. All others will then be left out. Clear? That is the combination which gives you the statistically significant AR and MA terms, high R bar square, low AIC and low SIC. That will be selected for the estimation. Just you see the USA case. There are how many possibilities? 1 to 1. That is AR1 process and MA1 process with second difference. Second one 7 AR7 MA1. Third one AR8 MA1. Fourth one AR9 MA1. The fifth one AR13 MA12. There are 13 AR terms, lag terms, and 12 U terms or MA terms. Just to see the parallelogram here, then you will. This is USA. USA's parallelogram means autocorrelation function and partial autocorrelation. Clear? This 1 and 1. There are two spikes. First 1 and 1. So I had my 1 and 1 case. This one. This 1 2 1 case. Then 7 2 1. 7 and 1. Therefore, one in the 7th lag, there is again there is a big spike compared to the earlier. So I take the 7 corresponding to the combination 1 for emitter. Then I go for 8, then 1, then the last in the 12 figure is 12 and 13. Clear? So sorry, 13 and 12. This one 13 for air and 12 for MA. So I had to estimate all the models in every country. So what are the results? Just to take the example of USA, then all others will be considered or calculated in a similar fashion. What is AR1 minus 0.14? It is less than 1, no problem, but it is not statistically significant. P value is 0.15. MA is significant, but AR is not significant here. So the AR1, MA1, and 2, this model is not accepted because primarily they are not significant. R square, R bar square is 0.4, AIC 21.17, SIC 21.2. Now take the second model, AR7, MA1. We have your statistically significant result. Both are statistically significant and less than 1 coefficient. R bar square has also increased 40 to 41, but AIC has increased 21.19 now. It was 21.17. The information is getting increased. That means you are losing your confidence of the model. So I cannot accept this one. Now we come to 8 and 1. What you see? That again they are statistically significant. R bar square has increased, but this AIC and SIC are both greater than this 21.17 and 21. So I cannot accept this one again. Now 9 to 1. AR9 is minus 0.25. It is 0 probability. MA1 is again statistically significant. R bar square is 0.43. Again increased. information is again back to the AR1 process. The SIC is again back to the MA1 process. So what happens that we have high error square relatively with low AIC and SIC. And the final outcome, the final model AR13 and MA12, you see that this MA term is not significant statistic. So I cannot accept this one. That's why I have bold marked this model of for USA 921. This model actually will be helpful for estimating the for forecasting the coming 60 days scenario of number of incidences for this. Clear? In the similar way, I have calculated UK. That was very first model was the estimated an optimum model AR1, MA1. This one for Italy it was AR71, and all the programs are accordingly given. Now come to the cases of Spain, France, China, India. For Spain, it was your AR hello AR21. For France, it is AR11. For China, it is 128. AR1 and MA2 terms were 28 years back, 28 days back, because we could not predict Chinese cases. So that's why it was some unusual result, but there is some possibility of forecasting. And for India, it was AR1, MA2, and accordingly, I use all the estimations are made using the EView software. You can use any low version software also for the use for forecasting any data. I used also new package. Then the result was this one. That was the scenario of USA. It was 83 lakhs. So in the last day, that is on 9th September, 11th September, it was 83 lakhs 75,901 was my forecast value for USA. For India, it was around 41 lakh 68,858 number of cases on that particular 11th September. What is about all the other countries? This is the case of UK. It was 3 lakhs 4,877 on this particular day, and accordingly all the results were there. What was the actual scenario? So I had to also check after the 60 days over, what was the actual scenario, whether my forecast matched with the actual scenario or not, whether the box Jennings methodology was justifiable or not. So what I found that USA's actual figure was 65 lakhs on that 11 September 2020. My forecast was 83 lakhs. UK's actual was 3.6 lakhs and forecast was 3.05 lakhs. It is very much closer to UK result. Italy's case was unsimilar. Spain's result also unsimilar because their downward trade had already started for that particular phase of forecasting. France's case also the unusual, that is mismatching forecasting. China's case almost similar. 85,000 was my forecast data. 90,000 was the actual data. For India, it was 45 lakhs actual data, but forecast data was 41 lakhs. So my result actually well suit to India, UK, and France, UK and China. Though I cannot predict China, but India and UK cases are very, very closer to the actual values. Here, so this was the work, and that was my published work. That particular work was published in a non-linear size journal, Chaos, Solitons and Fractals. The name of the journal is HDPR journal. Its 22 impact is 9.9. So very highly impactful journal. It's not the open access journal, it is a hybrid journal. I did not pay for it. So it was the actually this is the result of my calculations, my estimations, my exercise. Clear? So this is the result. So now I come to the practical scenario. How can we estimate your using a huge program? I am now opening the use file. So can you see this one, use file? Hello?
No, sir, it is not displayed.
No, so that means I will have to close this screen. Now I am going to share another screen, the view screen. Now the internet. So can you see the file now? Screen now?
Yes, sir. Now we can see it, sir.
Okay, okay. Thank you.
Yes, sir.
Okay, so this is the work file. China, this is Chinese data. That was from 21st January 2020. This is the original data up to this one, 11th July 2020. This NA are basically the values to be estimated or forecast. That is the 60 days data are there, which we have to forecast what would happen in the next days, in next 60 days. So what the first round, in the first stage, what you have to do, that you will check the P value, D value and Q value. So first of all, I go for testing the unit root of this series, because I will have to identify the order of integers. So I first go for level, then this is augmented decupolar. Okay, there is for China, since we do not have real data, so the level form stationary. Clear? Again, if you go for second difference, first difference, again there is second difference, first difference stationary. So if we, since China's result actually not suitable to me, I stick to India's data. These were India's data. In 21st January 2020, there is no cases for India. Actually, the first case was 27 January 2020. Only one people was identified on that particular day. The next 2 days there was no cases. Then in the next 3 days there were 1 cases. Then the cases started rising. So you now start with the same process. Unit root, level, then okay. So what you see, probability is 1. That means it is very highly insignificant, highly non-stationary feature of this level form of the series. So what we do, I go to the second option, first difference, then we see again there is the situation of non-stationarity because there is no negative value because your 1% level is minus 3.4, 5% 2.87, etc., etc. So again we accept the unit root rho equal to 1 or beta equal to 0. Now again I go for the second difference option. What we see is minus 13.57. Probability is well less than 0.01. Clear? So what is the conclusion here? That the series is second difference station. The India's COVID incidence series is stationary at the second difference. So now we get the value of D as 2. Then the situation is for P and Q. Since it is second difference stationary, you will have to go for parallelogram. Parallelogram meaning the combination of, which shows the combination or diagrammatic features of HCF and PSCF autocorrelation function and partial autocorrelation. Since it is the second difference stationary series, so I will opt for second difference here. So these are the autocorrelation function and partial autocorrelation. Here again 1, 1, 1, 2. Then again you can go for these 7, 8, 9 also. There are so many possibilities. So I have here the situations of so many terms. So what I got in case of India, let me check what the Indian was. India was AR1. India's case was AR1, that is AR1 and 2. So AR1, that is first spike was there at lag 1. Then the second lag for MA, it is significant. And it is tested through our diagnostic checking that these combination AR1 and MA2 with second difference option gives you the robust result. That means your AR1, MA2 will be statistically significant. Their values will be less than 1, or stationarity phi less than 1, and the R-bar square will be maximum. AIC and SIC information criteria will have the values minimum possible. Clear? So on the basis of that estimation, that is your AR1 and MA2, you will have your estimation. How?
Excuse me, sir.
Yeah, please.
Yeah, can it be AR1 and MA1?
Maybe AR1 MA1 also be there, but the robustness is not there. That is AR1 MA1 gives you the MA1 is significant, but AR1 is not significant because its probability value is 0.79. That's why I had to reject this one.
How to identify, sir?
How? Yeah, please.
How to identify?
Yeah. I have actually given already said, but I am coming to the practical application here. So I am going to say AR1 MA1 model first, right? AR1 MA1 model for your purpose. So I am going to estimate equation. Clear? What my data was? Second difference. So I will write D, then India. Clear? So this is the second difference value or series of Indian COVID incidence. Then you can add the constant term C. Then your term is AR1 space MA1. Clear? I'm taking this one as common next course. So then I go for OK. So what you see? This one. For the coefficient of AR1 minus 0.03, its probability is 0.79. T value is very low. Clear? MA is significant, but AR1 is not. R bar square, adjusted R square is 0.21. AIC, SIC are 17.16 and 70.22. Clear? Now again I am estimating the second one. So just you keep in mind that adjusted R bar square is here 0.21 and AR1 was not significant. Now I am repeating this one for AR1 estimate equation. Then I again this one, but I write down here MA2, not MA1. Again I enter. I am deleting the earlier equation. What we see that AR1 is significant, right? 0.00 probability. E value is very high, minus 7.04. MA2 is again significant with very high T value. Adjusted R square is 0.21, similar, but AIC and SIC are 17.16 and 17.22, little bit smaller. But the important thing is that AR1 is significant here. Here now come to AR1 and MA7. That is the last option for India. I'm again estimating the same similar fashion. Now I'm writing 1 and 7 because there was a spike in SCA for MA, the 7th line. LH. What we see that AR1 is significant, but MA7 is not. R bar square has gone down to 1.14, and accordingly AIC, SIC have gone up. So what is my ideal model now? AR1 and MA2. Clear?
Yeah.
Now I am going back to this model again because I have to make estimation or forecasting on the basis of that particular model, AR1 and MA2. Now again I go to quick because I have to repeat this system again. This one I am writing AR1 MA2. Now this is the model. Now we go to forecast. Just you see that this is the forecast. Can you see the forecast button? Forecast button here. But before to forecast, you will have to resize your sample. Why? You will have to make sure how many days or how many forward time periods you are considering for your forecast. For my study, the 60 days later, so I will have to resize the sample by just double clicking. I am minimizing this one, this one. This is the range of data, sample range. So just to double click here, then there will be data range. You will just augment or add the future periods. For me, it was 60 days addition. Clear? So that is the resizing of sample. After you resize, you just created the space for the forecast data to enter there. Otherwise, the forecasting data cannot be entered there. Clear? So I am again using this. This one, it was my ideal model to my diagnostic checking. It was the robust results. So I go for forecast. Clear? What the computer system is giving you? India and DD of India. I do not want to forecast the double changes of the COVID incidence. I need the level. That's why it is important to it is automatically selected by the system. That is India level is selected for forecasting, and the forecasting is dynamic forecast, and the forecast sample is 21, 22, 9, 11, 2020. Clear? So I given give okay. Is it right? I am putting the OK button. Pressure. So this is the forecast values. Just to remind my forecast series for India, it was looking like this, and the red two are the standard deviation plus minus 2 standard error. So this is the band. These two, within these two bands, the forecast value will be there. In the right box, there are some statistical measures. One is to have root mean square error. We will have minimum root mean square error. Since for India there are 3 models, alternative models. If you wrongly forecast with the unacceptable models, then there will be these types of figures also. But these values, the root mean square error, they will not be minimum. The bias proportion, variance proportion, and covariance proportion will not match. It will go higher and higher. So these bias proportion, that is bias proportion means how much the actual value deviates from the forecast. How much the mean value of the actual deviates from the mean value of the forecast. Variance proportion means how much the variance of the actual series is away from the variance of the forecast. For covariance, the covariance is there. Usually these 3 values should be lower to have the good forecast series. So that's why you need to have thorough diagnostic checking. You should be careful in checking the model or testing the model or accepting the clear. So that is the case for India. I hope you can use any data in your study area and follow these types of steps. Then you will be having a good forecast value. So,
Excuse me, sir.
Yeah, please.
RMS is very high in this case. Can we continue?
No, very high. In this case, it is 79,961. But
Yes.
if you take the another model, say AR1, MM1, it will be further higher.
Okay. Then
Right.
what is the conclusion from this? Can we
Conclusion
forecast?
Yeah. That is, since my ideal model is AR1, MA2, and on the basis of this particular idea model, I actually give the forecast. Not I use the 2 unacceptable models, AR1, MA1 and AR1, MA7. Once you identify your ideal model, ideal structure of this AR-MA, then only you can use the you can go for forecasting. So if you run the forecasting for other 2 non-ideal models, then you will be getting these types of figures also. This the same type of box for other information also. But if you compare the root mean square error for this data result with other results, then there will be difference. This one only give you the lowest root mean square value. Definitely. Right?
What is the ideal value of RMSE, sir? How much?
No,
it should
there
be?
is no such ideal.
Okay.
See, suppose there is 100 marks exam, right? Ideal value means maximum value is 100. Non-ideal is 0. Further non-ideal is negative values. So I cannot ensure which
But there
one
is a
will be
pass
the,
mark of 35%.
yes, but someone also scores less than 35 percentage marks.
Then it is a
Sometimes
failure.
failure, maybe. Clear. But in this case, if you forecast with 3 alternative models for India, then you can identify which one is better and which one is worse.
Okay. So in this case, we need to try with other models also, right?
Yeah. I have actually tried, because R square was not maximum there. AIC, SIC values were not minimum there. Only the model AR1 and MA2 were all the AR1 MET coefficients were statistically significant. Their R square was maximal or at least equal, and AIC SICs were at least equal, not greater.
Sir, can you please repeat that portion in the choreogram where we only take the lag of 1, 2, and 7 among the others? Why did we take 1, 2, and 7 lag and compared among only these three? So can you please?
Okay. Just I am repeating this one. Can you see this one?
Yes, sir.
Okay. So what we see that for AR process, there is only one spike, major spike, right? So I will be taking AR1 always. For MA, there is first one can be taken, that is MA1, second one MA2, third one MA3, fourth one MA4, and then after fourth, all are dying out. Again in the seventh or eighth, again they are taking some spikes. So you can take for India AR1 MA1, AR1 MA2, AR1 MA3, AR1 MA4, then AR1 7, 8, 9. No problem. Clear? There will be so many possibilities, but you will have to identify through your diagnostic checking which one is giving you the ideal result, robust result. That particular ideal model will be accepted for forecasting. Otherwise, all results will be dicey and self-conflicting.
Sir, apart from checking the significance, the coefficient value has to be less than 1.
Yeah.
Okay, sir.
That is 5 should be less than 1. Otherwise, there will be divergent situation. The roots will be outside the unit circle. Non-stationary nature. Unless you control for non-stationary issues of the data, I cannot estimate or I can proceed for forecasting. This is very primary requirement.
Sir, the forecast sample period, can you please once again tell? The
Sample
actual
period.
data is not from 121 to 2020, right, sir?
Yeah, the actual data is from 21st January 2020
Okay.
to 11th 11th July 2020. This is my actual data.
So
Clear?
forecasted for 2 days.
For 60 days. That is from 12th July 2020 to
Okay.
11th September 2020.
So for the entire period you are forecasting, sir.
Yeah. Since I have long original value series, that is around 193 days.
Sir, one more doubt, sir. When dynamic forecasting is used and when static forecasting is used?
Actually, forecasting basically dynamic. Clear?
Okay.
Once you go for any say short period forecasting for any business data, suppose you want to launch a product for any particular market, you just want to see in the coming in our state, for example, in coming Durga Puja festival season, how many new Apple phone will be sold out. That is very short term forecasting. In that case, huge dynamism is not required. But if we want to continue for several festivals, several years, then there is the use of dynamism. We actually will be using huge past values.
Can this forecast be done by dividing the data into trained data and test data?
Maybe, but once you do not combine AR and MA, you do not have this type of RMA structure model. Yeah. So since the model is RMA, you will have to combine these two. You cannot segregate the trend from the total series, right?
Okay, sir.
You will have to take into account both the series, both the concepts of the data. Any question, please?
Any more questions, please? Sir, I think they have well understood the session.
Okay, so if there is no more question, so I should say thank you all.
Yeah, sir, just wait a minute. Let me give you a formal vote of thanks. I request Oishik to do the honor. Oishik.
Yes, sir. Thank you, sir, for this very insightful session. It was a very insightful session from Dr. Ramesh Chandra Das, and I believe the participants have benefited a lot from his presentation on various forecasting model and time series model. On behalf of the FDP team, I extend a hearty vote of thanks to our research person, Ramesh Chandra Das sir, for sparing his time to grace this occasion. Today, we had an opportunity to hear your thoughts, and this will surely be going to guide us in our future research works. I would also like to thank the conveyors and organizers of the program, Dr. Digjyoti sir, Dr. Shravanti ma'am, and Taraknath sir for organizing this session, which was very detailed and insightful. Also, thanks to all the coordinators and backend teams who have been constantly supporting the proceeding of the programs. And lastly, thank you to all the participants for patiently listening to the research person and your sincere coordination. With this, we have reached to the end of the 16th session of this program. And over to you, Dipjyoti sir.
Yeah, thank you, Oishik. And Ramesh sir, thank you to again for
Okay,
giving
thank you.
us
Welcome,
your
welcome.
precious time and engaging with us. I hope to listen to you in future too, sir.
Okay, thank you.
Thank you, sir. Thank you. Thank you
So
and good.
try to send the video recording of this.
Yeah, definitely. We are sharing to the participants every day the recordings in the YouTube.
Okay,
If you want, I can give you the link too, sir.
okay, thank you.
Okay, thank you, sir.
Okay, take care. Take care of it.
So participants, we are ending the day here and we'll meet again tomorrow at 4 p.m. Thank you.